Hello, my name is Paul Thompson, and I am going to be answering questions for math, chemistry, and physics. I have a physics question to my right here. This is my first time doing this, so please go easy on me. So, we have a 6.86 kilogram piñata here, and I already drew out the schematic that you can read through here, and this is how I interpret it. So I'm going to redraw this a little better looking. That's our piñata, and this is not to scale. 1.22, this is 1.573 plus 0.354 and 1.573. Okay, so first thing I like to do is find out what the angles are here, calling this theta 1 and theta 2. We can do this by using our trig identity as being opposite over adjacent for 1.22 and tangent theta 2 is equal to 1.573 plus the 0.354 divided by 1.22. So I already had plugged this into my calculator just simply by doing the inverse tangent, and I got theta 1 to be 52.2 and theta 2 equals 57.7, and these are degrees. Alright, so now I want to go and draw a free body diagram with our piñata. This I will call T1, and this I will call T2, and we have the force of gravity, which I'll call F of W. So you look at this diagram, and all the forces will add up to 0. But you can break it down and see that the x component of T1 and T2, so T1 of x and T2 of x, are going to equal each other. Well, the magnitudes will equal each other. And so this is negative T1x equals T2x. I get this negative here from because I set my coordinate system here, this being the positive y direction, and this being the positive x direction. T1 of x is pointing in the negative direction. So I can break this down to be cosine theta 1, our angles, can't forget those, very important, of the tension 1 force, and cosine theta 2 times T2. And can't forget this negative here. So I'm going to solve for T1. You'll see why later in the video here, by dividing by negative cosine theta 1. So do this real quick here. There. Alright. Now, this is as far as I'm going to get for this part here, because I don't have another equation. I have two variables, one equation. I can't solve this. So now, I have all my forces in the y direction. So this will be the T1 of y plus T2 of y. It's going to minus the f of w is equal to 0. So we can break this down into sine theta 1 times T1 plus our sine theta 2 T2 minus our mass times gravity constant there. So now I can change the color here. I can plug this equation here. This is why I solved for T1, and plug it in right there. And we can't forget that this equals 0. I'm sorry here. So sine theta of 1 times negative cosine theta 2 T2 divided by cosine theta 1 plus sine theta 2 times T2. I'm going to move this mass times gravity here, gravitational acceleration, over onto the right. So now, try and add another page. There we go. So, load up. There we go. So, now I want to solve for T2. You can do this by taking the T2 out of the equation and separating as if T2 was some constant. When we do that, we have T2 equals mg all over the sine theta 1 times negative cosine theta 2 over cosine theta 1, and that was plus sine theta 2. So now this is just plug and chug. We already have our mass, gravity, for the theta 1 and theta 2. And when we plug this into our calculator, we get 429.9 newtons. Okay, so we solved for T2. Now all we need is T1. That's where our other equation comes in. Let me see, there's a way. Forget it. I'll just rewrite it down here. So T1 is equal to negative cosine theta 2 times our T2 all over cosine theta 1. Now you can also plug this into the calculator because you already solved for T2. And you get negative 374.8 newtons. Alright. Oops. Correct that. There we go. So, here's our answer. And the reason why this is negative was because our T1 was initially in the negative direction. If you want, I would just call it positive because we're trying to find out the magnitude of T1, really. And we're not assigning any vector components. So, plus. Okay. Thank you. Subscribe. Ask questions. Thank you.